coefficients represent moles. If we know moles of one thing, use coefficients from reactions to turn it into moles of something else. Always I get moles if it is not given in the problem. Balancing equations example. Use the equation S plus HNO3 reacts and forms H2SO4 plus NO2 plus H2O. Take your elements, example SHNO, as mentioned in the previous example. Then take the numbers of each element and write them down in pencil. Do not use pen. This will come in handy later when you need to change things. Then you change the coefficients to make them all being all of the elements, all the same. That's your balanced equation. Now when you need to find the answer to a question, there's 3 types. 1, 2, 3. We'll start with 1. How many moles of sodium are in 43 grams? You take 45.3 and you take that and you multiply by 1 mole over 23 grams, because that's the gram formula mass of sodium. You get 1.97 moles. For two-step problems, it's not really different than one. You just add a mole-to-mole equation. Example, how many grams of NaIr produced from 3 moles of Na2S? You take your 3 moles of Na2S, you do a mole-to-mole ratio 2/1. Then you take your gram formula mass. Now it's on top. You take 150 grams of NaI and divide by 1 mole to get 900 grams of NaI. 3-step problems are the most complicated of all. You take the thing, you do a 1-step plus a mole-to-mole plus another 1-step equation to get your 1 plus 1 plus 1 is 3 steps. Example, how many grams of AgI are needed to make 37 grams of silver sulfide? 37 grams times 1/247.8 multiplied by 2/1 mole. Then multiply that whole thing by 234.8/1. You get 70.1 grams of AgI. And that's your 3-step problem. The reactant that is completely consumed produces the least amount of product. It will give you the amounts of 2 or more reactants and ask you to find an example. A 2-gram strip of zinc is placed in a solution containing 2.5 grams of silver nitrate based on the following reaction. Zn plus 2AgNO3 reacts and forms ZnNO3 2 plus 2Ag. How many grams of silver are formed? You write your 3-step equations, and you get 6.4 grams of silver and 1.59 grams of silver. So you take the one that has the least because it's the limiting reactant. Percent yield. Does anything ever go to completion in a real lab? No! That's why there's theoretical yield. It's the amount of the product of all the limiting reactant reacts you get by doing a stoichiometry, a mass, etc., or a limiting reagent problem. It can be in mass or moles. Your actual yield is the actual amount of product usually given to you in the problem. It's really great because the number's already given to you. You don't even have to do any work for it. See how that works? The formula for percent yield relates to the theoretical to the actual. Percent yield equals actual yield over theoretical yield times 100%. Empirical formula. Step 1 usually given either grams or elements or percents. If percent assume 100 gram sample, turn percent to grams. Step 2 convert grams to moles. Step 3 if moles are decimals, locate the smallest number of moles. Step 4 divide all the values by smallest moles. It gives you your mole ratio. Many things important in stoichiometry, but most importantly, remember these. These are all very similar problems. Stoichiometry hinge on a few main ideas. The mole is the unit of comparison, not the gram. Balanced chemical equations tell us how many moles are part